HT6 experiment, and I'm going to give you sort of a brief overview of what we'll be doing. What we're doing is measuring the thermal conductivity of this piece of glass. How we do it? Well, it's kind of an interesting idea. In this upper container we will have boiling water, and this is thermally connected to this lower spot here. And so once the water is boiling, because metal is a good conductor, this will be at 100 degrees centigrade. The heat will transmit through the glass plate and it will heat this part of the device up. Now, most of this is just insulation. What matters here is this chunk here. This is a chunk of copper. I know it doesn't look copper colored because it's been plated with nickel, but this is a chunk of copper, the mass of which is given here, 350 grams. So you can imagine that, when I have boiling water in here and I have this at room temperature, there is a temperature difference between them. The temperature difference causes a voltage to be produced. Now, I don't want to go into the details of this here, but I'd like you to take a quick look at Appendix B, and this will sort of explain why we get a voltage difference. Unfortunately, my piece of wire fell on the floor while I was talking. Hang on. There we go. Okay. And so what we're doing, we're connecting this part here up to this part here. It's kind of a bit fiddly. Okay, old sausage fingers here, struggling with it. There we go, okay. And if we swing around and look at the voltmeter at the moment, here, the voltmeter is showing essentially no volts. That's in millivolts, right? So we have a very low voltage coming out of it, because at the moment, these are at the same temperature. It happens that I have a kettle here and I just boiled up the water. So let's do as a quick experiment. I'm going to pour some boiling water in here and we'll look at what happens to the voltage when I do this. Hopefully it works. And we can see the voltage increasing because we now have a temperature difference between this metal and this metal here. It's a thermoelectric effect. Now, the rate at which the plug heats up depends upon the thermal conductivity of the glass. You can imagine that if we had a metal-metal contact, that would heat up very rapidly. Because we have the glass in between, it heats up more slowly. Again, I'm not going to explain all the theory here because it's easier that you just read the book. But what we find, it's an exponential process. Let's not get too much into exponential processes at the moment. But the theory tells us, it's a bit involved, that the time constant, and this will be a bit like the capacitor lab, we have a time constant, and the time constant is related to the thermal conductivity. So you sort of have to look at this equation here. Other things we need before we start the experiment is the area of the plug. Obviously, the rate at which heat enters the plug depends upon its area. So we're going to use the calipers that we've used before to measure the diameter of the plug, like that. There's a value. The other thing we need to know is the thickness of the glass plate. I'm going to carefully take this away, and for that we would use the micrometer, which we're familiar with, and would measure it in a few places and take the average. I think that's pretty straightforward how to do that. Okay, so what will happen is that that we need to get this water boiling. We're going to use an immersion heater for that. And once this water is boiling, we'll have a large voltage difference. When I push this underneath, this will start heating up and the voltage should drop off. Okay, so I'm going to sign off for now. I'm going to get the water boiling and I'll come back to camera once the water's boiling away. Okay. Hi folks, so we're back and the water is boiling, the system has stabilized, and we can look at the voltage now. We have 3.19 millivolts, so this is the highest voltage we're going to get. So what I'm going to do, I'm going to push this one underneath now, and when we look at the voltage, we'll see that the voltage starts going down. Now, the rate at which heat goes through here depends upon the temperature difference. So initially the voltage drops quickly, but as time goes on and this one heats up, the temperature difference diminishes, which means that the heat goes through less quickly, and so the voltage drops less quickly. We've talked about this in class. This means we get an exponential curve coming out of this, right? So when we look at the voltage drops off exponentially. So one thing I forgot to mention is that we also need to know the specific heat capacity of the plug. We haven't really discussed this, you'll have to look at your notes, but the specific heat capacity of the copper tells us how rapidly the temperature of the copper changes as we put in heat. Water, for example, takes a lot of energy to heat water up. It takes less energy to heat copper up, right? Copper gets hotter faster with the same amount of heat. In the equation, there's a C. That's the C in the equation. It's in the text. You can easily find that yourself. Okay, so I'm going to push this underneath now. When I do, I want the video to look at the voltage and see how the voltage change. Of course, I have to be careful here. So for safety reasons, at this point, I'm going to stand up. In case anything spills, I can quickly step away, safety first. And so what I have to do, I have to sort of push this one like that. Right, and so now the heat is transmitting through the glass plate. The block is heating up, and we should see the voltage start to drop. What I'm going to do now is also start a stopwatch, and what I'll do is I'll gather the data as the time goes on. I'm going to record those voltages, and that will be the data which is already in the spreadsheet ready for you to analyze. So let's take a look at the voltage. And you can see the voltage dropping off, right? As the temperature difference between the two components decreases, right? The lower block is heating up to become closer to the temperature of the upper block of copper. Yeah, I think that's about the experiment wrapped up. So what you'll get is a spreadsheet with the dimensional data of the glass plate in and some voltages as a function of time. You'll have to plot up the exponential decay, and you'll get tau, the time constant of that, from the B in the fit, and then you throw the numbers in. Be careful with units, and you should get a reasonably good result coming out of the data. I guess everyone's going to get the same result because they're all getting the same data. But a pretty nice, straightforward experiment. Okay, I'll sign off there. I think that's all I really need to show you. You can see the voltage is still dropping. Okay.